Okay, so today I'll be going over the fall 2023 sample problems for the final exam for 1410. All right, so we start with this first problem. It says that we have a Taylor series expansion for this function f about the origin, and they say which of these apply to f. So for this question, this requires knowing like how is a Taylor series in multivariable calculus written? Each of the terms in the Taylor series are written as like for some I, it's written as 1 over I factorial, the derivative to the I power of f, and then x to the I. What this means is that, say right now I have two variables, x and y, right? So that means that if I wanted to find, for example, I corresponding to 2, 3, or actually let's do 3, 1, because those are the ones in the problem. What does an I of 3, 1 mean? It means that the term corresponding to that in the Taylor series is 1 over 3, 1 factorial, d to the 3, 1, I, f, ln x to the 3, 1. Meaning it's 1 over 3 factorial, 1 factorial. This d to the 3, 1 means that I want to do the partial of f. 3 plus 1 is 4, so there's 4 times. And which variables am I doing them to? I want to do x 3 times and y 1 time. Because this 3 corresponds to x, this 1 corresponds to the y. And this x to the 3, 1, this means whatever variables you have to their respective powers. So x cubed y. So we see just in this like first thing, what are the first three answer choices? All the first three answer choices are like asking you, what is the partial with x 3 times and y 1 time? So we want to find this. In order to find that, we have to see, do we see an x cubed y term in our Taylor series? X cubed y. Oh, and I guess because we're centered at 1, 0, you can, just like how a normal Taylor series in single variable calculus, if it's not centered at 0, 0, you just do like x minus 1 and then y minus 0 because the center is 1, 0. So do we see an x1 cubed y term? Yes, we see it here. That's this term. So that means that this term is equivalent to this whole entire thing. So let me write that it's equal to x minus 1 cubed y. So that means that what are the coefficients? I have 1 over 3 factorial. This partial, it should equal 1 because I can imagine canceling this out, right? So I get this equals 1, which means that the partial of x 3 times y 1 time is 3 factorial. What is factorial? You go like 3 times 2 times 1, which is 6. And are those any of our answer choices? No. So I know that all three of these are not correct. Where did I get the 3 and the 1 from? It's because I'm looking at the answer choices and they're asking me for the partial of x 3 times and y once. So that means that the first number should be 3 and the second number should be 1. If they wanted me to find, for example, like the partial of x twice, y 3 times, what does that mean? That means an corresponds to an I of 2 comma 3. Where the term in the Taylor series would be 1 over 2 factorial, 3 factorial, the partial x twice y 3 times, and then x twice y 3 times. So if I wanted to find this partial derivative, I would see, do I see a x minus, in this case, we're centered at 1. So do I see an x minus 1 squared y cubed term? No, I do not. So I don't know what this partial is in this question. But hypothetically, that's how you would do it. Why did I cancel x minus 1 cubed y? Uh, so, right, I'm trying to find this partial derivative. And I know that the term in my Taylor series that contains this partial derivative will look like this. Will look like this left-hand side thing. So I try to find, can I see an x minus 1 cubed y term in my Taylor series? I do find it. It's right here, this highlighted one. So that means that this term is written like this way. Like this is equal to this. So I wrote that is equal to what I found in the Taylor series. And remember, I'm trying to solve for the partial derivative. So it's like you have an equation. This equals this. How do you solve for the partial? I could like cancel out the x1 cubed on both sides and the y on both sides. Or you can also see that like I want the coefficients to match. The coefficients in front of the x1 cubed y is this thing. So I have that here. And the coefficients in front of x minus 1 cubed y over here, the coefficient is 1. So I put the 1 there. And then I solve for the partial. So the whole process is like, what does the term in the Taylor series look like? Can I find it in what they're giving me? If I can, set them equal to each other and solve. Okay, so far I know these three are not our answer choices. What else can we say? So remember that one quiz question from one of the weeks? I also went over it during my summary review session from Saturday, I believe. That Taylor series question on the quiz, it was like they gave you some function g of x, for example, equals e to the x plus y, cosine of something, and sine of something. And they said that like you have a critical point at the origin, classify the critical point. That was like the quiz question from a while ago. Quiz question. And how did you do that problem? Well, we found the Taylor series for e to the x plus y to be 1 plus etc. And we found the Taylor series for cosine to be 1 plus etc. And then we found the Taylor series for sine to be x plus y, etc. And so we looked at the leading terms, like the lowest terms in each of our Taylor series components, and we multiplied them up to say that g of xy equals 1 times x plus y plus a bunch of other terms. And we only cared about that main term. We only cared about this x plus y. Actually, I think it was x squared, y squared in the problem. X squared like that. Or something similar. And so we look at this lowest degree term, and now we have to look at its behavior. What happens as, oh, I think it was actually minus also. Minus squared, like that. So we looked at what happens as x increases. Well, we get some huge number, minus y squared, which is a positive number. And then we looked at as x decreases, same thing happens. We have some huge number, minus y squared, so that's positive. And we also looked at what happens as y increases and y decreases. We get super negative because we have x squared minus some huge number, big number. And this was negative. So in one direction, we had this like values keep getting bigger. We got this like minimum. In the other direction, in the y direction, all of our values kept getting smaller and smaller, some like maximum behavior. And so this was a saddle point. Because in one direction, something was happening. In the other direction, the other thing was happening. Like a different behavior was happening. So using this similar idea, we're going to use that for question 1. I'm going to look at what is my lowest degree term? Or like my, I guess I should say highest, like lowest degree. No, it's still lowest degree term. Whatever has like the least exponents. So looking at my first term, the 1/2 x minus 1 y squared. So I'm going to look at 1/2 x minus 1 y squared. And I'm going to see what is the behavior around the critical point. They're saying that my critical point is 1, 0 for each of my choices. So I'm going to see, is it a min or a max or a saddle? Well, what happens as x increases? As x increases, these numbers keep getting bigger and bigger and bigger, right? Because we have like 9 minus 1 would be positive 8, okay? But if x is like 100, this becomes negative, this becomes 99 y squared. If x is like 1,000, this is like 999 y squared. So it keeps getting bigger and bigger and bigger. As x increases, f gets bigger. Let me move this down. Okay, what happens as as x decreases though? Well, let's say x is like 10, or let's say it's like 1. Then we get that f is 0. What if x is like 0? Then we get negative 1/2 y squared. What if x is negative 10? We get that f is 1/2 negative 11 y squared? What if x is negative 100? So as we get more and more negative, f keeps getting more and more negative. So f gets negative. And instead of saying bigger, let me say positive. Okay, so that's the x behavior. Let's look at what happens to y. As y increases, what happens? Any number squared will be positive. So no matter what, this f term will keep getting bigger and bigger and bigger, or more positive. It's positive. What about as y decreases? Any negative number squared, it's still going to be positive number. So f still gets more positive, even if y is negative. So we see that there's like these differing behaviors that are happening. Like not if all of these were like positive, that means that in all directions, every single direction, all the values keep getting larger and larger and larger, and that would be a minimum. Or if all of these behaviors were all negative, that means all the values are getting smaller and smaller and smaller, and so you would have a maximum. But right now we have these differing behaviors. Like as x increases, f is getting bigger, but the other way f is getting smaller for some reason. And then for y, it's always getting bigger. So because there's this like mix match, that means that we have a saddle point. So question 1 should be saddle point. Questions on this question?
Could you repeat so if it was a local minimum or like a local maximum, what would the behavior be?
Yes. So you want to look at you start at your critical point and you want to see what happens if x increases and decreases, you get your values keep getting positive. F gets positive. And as y increases, y decreases, f also gets positive. Then you imagine that at all sides, in all directions, I guess you could say, in all directions, f gets positive. Like no matter which way you turn left, you turn right, whatever, f keeps getting more positive, so f keeps increasing. And what does that behavior look like? If you're like increasing every single side, that looks like a minimum. If as x increases and decreases, f gets negative, and the same thing happens for y, f gets negative. Well, from all sides, if your values keep decreasing and decreasing, that looks like a maximum. Question, can you repeat how you need to look at the 1/2 x minus 1y squared term to classify? Yeah, I want to look at the lowest degree term because like all these other terms are essentially like extra information. They're like higher ordered terms, so they're like almost kind of redundant. They're like giving you extra information. So we only want to look at like the main term that is like the biggest term that's giving us all the information. Um, so yeah, always look at the lowest degree term.
Do you always look at the lowest degree? Like, what if it's diverging? Like the Taylor expansion is increasing, like each term is getting bigger and bigger. Wouldn't that make a difference? Or do you just always look at the lowest term regardless?
Always look at the lowest term. Like see here, the terms are like
Mhm.
the degrees are increasing here. Like this is degree 4, this is degree 5, this is only degree 3. So the terms keep like increasing, but I only looked
But
at
what if the terms were like alternating? You know what I mean? Like some were increasing in the positive direction and some in the negative. Do you still look at the first term?
so if like two of them had degree, if this one was like degree 3, then I would look at both of them together. So look at
Wait,
find the lowest degree, what is the lowest degree possible, and see all the terms that have that degree. So if I had
oh,
Taylor
okay.
So if my Taylor series was like 1/2 x minus 1 y squared plus 1/2 uh or like plus I don't know.
X minus one squared y, like if it had the same degree. Oh,
Yeah,
okay.
x
Got
minus
it.
yes. Then you look at like that. Okay. Is the lowest degree term the term that has the least? Yeah, the least number of powers. Like you add up the powers. This is degree 3. This is degree 4 because 3 plus 1. This is degree 5, so on. Can we just find the Hessian matrix to get the answer? I wouldn't use the Hessian matrix. In one of the ed discussion posts, and also I recommend looking at this post number 157 on ed discussion. I'd recommend looking at that one. The way they write the questions, or I mean, you could look at the Hessian, but in this question, I don't think it works. So you can look at that ed discussion post. The only reason like the Hessian would, like, okay, if you have a function like this, don't like take the derivative and take the derivative again to get the Hessian matrix. If you want to use the Hessian matrix, you have to use this method of finding where are the correct partials that you want. Like the Hessian matrix is composed of the partial of x squared and then yx and xy and y squared. So if you want to do the Hessian matrix way, you have to see like, where is this partial derivative? This term corresponds to the I equals to 0 term. But the problem here is that I don't have an x minus 1 squared term anywhere in my Taylor series. So if it's not there, you can't just assume it's 0. Or like, I wouldn't just assume it's 0. So you can only use the Hessian matrix if you're actually able to find these points. Then sure, use the Hessian matrix. Otherwise, you should use this like behavior technique, which they explained in the ed discussion post. Using the Hessian matrix to find the critical point. Using the Hessian matrix to find the critical point. The critical point is always found by doing the derivative matrix equals 0 and like whatever dimension your matrix is. It's always like you set all the components equal to 0. That's how you find the critical point. Okay. Let's see. So lowest degree, does it look something like this? X increases, F bigger, X decreases. The person who sent me a picture in the chat, yeah, it looks something like that. Could you go over how we would classify the example Taylor series with 2 degree 3 terms? So you would do the same kind of, so if you had 2 degree terms like this, let me write this down here. You would do the same thing, like look at what happens as x increases, as x decreases, and what happens to y's. So let's see. As x increases here, this number gets bigger, this number also gets bigger. So f increases. As f decreases, this becomes like a negative number, right? For example, if x is like 2, you get f equals 1/2 xy squared plus 3, 2 minus 1 is 1 squared, y. As what if x is like -3? Then f is 1/2 -4y squared plus 3 -4 squared y. So you see that like this term doesn't really matter. It's always like positive, but this term gets negative. So I would say something weird is happening here. 1/2 y squared. I would say weird. As y increases, f is always positive because y squared is positive. This y is also positive, so this whole thing would be positive. As y decreases, though, the first term is always positive because any number squared is positive. But here you're always like subtracting something. So no matter what, if y is like 2, for example, you get 1/2 x minus 1, 4 plus 3 x minus 1 squared, 2. But if y is -3, what do you get? You get 1/2 x minus 1, 9 minus 3x minus 1 squared, 3. And I would say that this term is bigger because it has this x minus 1 squared. So this term will always be larger than the first term. So f is like being negative. So I would say that it's still a saddle point in this case. So it's kind of like you have to like keep testing stuff and seeing what is happening to the behavior in different directions. Cool. Okay. Any other questions on question 1? Yes, the word to determine it's a saddle is here. Can you repeat why C is not true? Yeah. So for A, B, C, they're asking what is the partial of f with respect to x 3 times and y 1 time. So I want to find this partial derivative. In the Taylor series, where does this partial derivative exist? Well, it exists whenever we see this term. Because a partial of x 3 times y 1 times corresponds to an I of 3, 1. In the Taylor series, an I of 3, 1 term is written as 1 over I factorial, the partial with 3, 1, and the variable with 3, 1, which means it's 1 over 3 factorial, 1 factorial. This D notation is the same as this partial notation, and variable to the 3, 1 is like x minus 1 cubed, y to the 1. So if I can find this term in my Taylor series, then that term in the Taylor series must equal this. The term in the Taylor series is x minus 1 cubed y. I found it. So that means that however that was written, it equals this entire thing. And so what would the partial have to be in order to get a coefficient of 1? The partial has to be 6, so that I get 6 over 6 cancels out to be 1, and the coefficient of 1 times x minus 1 cubed y equals x minus 1 cubed y. So it's not 1/6. If C was true, what would that mean? It would mean that the term in my Taylor series would have to be 1 factorial, 3 factorial, the partial, which is 1/6, x minus 1 cubed y, which would be 1 over 36. But is that my term in the Taylor series? No, I don't have a 1 over 36 here. If we were looking for a minimum, what would the x increase f pair look like? Yeah, if we were looking for a minimum, everything should be increasing, because what does a minimum look like? A minimum is like the minimum critical point is the smallest point. And everything else is increasing, right? So in all directions, you must be increasing if your critical point is a minimum. If your critical point is a maximum, like what is the definition of a maximum? It's like the largest point your function can have. So that means that everything else around it, all other points should have a lower value. So that means that for a maximum in all directions, f should be decreasing. F should be getting more and more negative, smaller. The positive mean becomes bigger and negative mean becomes smaller. Yes. So yeah, when I say like gets positive, maybe I should say, maybe it's better if I say f increases instead of like say positive increases. F increases, F increases. And then when I say negative, I mean like decreases. I'm able to say just like positive and negative because our critical point is like kind of in the center, like 1, 0. But say our critical point was like down here, like -2, 2, then a minimum would mean that like all the points are above it, right? So some values are still negative, but other values are positive. But the point is that it must be increasing. So if everything's increasing in all directions, minimum. Everything is decreasing in all directions, maximum. If you have differing behaviors, like increasing versus decreasing, then you have a saddle. Okay. Any other questions before we move to question 2? Here's the Okay, let's move to question 2 then. What shape is represented by the equation in cylindrical coordinates? Okay, so we have this cylindrical coordinates equation. Cylindrical coordinates, we aren't like that used to it yet that we know what everything in cylindrical coordinates looks like. But I do know what things in Cartesian or like the normal coordinate system looks like. Like if I gave you x squared plus y squared equals 4, you should automatically know that's a circle of radius 2, right? So I'm more used to Cartesian coordinates, and so instead of dealing with things in cylindrical coordinates, let's just convert this to regular coordinates, Cartesian, and see what it gives me. And maybe then I'll recognize what it is. So what are the cylindrical coordinate transformations or conversions? Cylindrical coordinates. X is r cosine theta, y is r sine theta, and z is z. These were our cylindrical coordinate conversions, right? Okay, so what is r squared? R squared, this is something like a tip, I guess. R squared is x squared plus y squared. Why? Because if I do x squared, I get r squared cosine squared theta plus r squared sine squared theta, and the cosine squared theta plus sine squared is 1. So I get r squared. Okay, so that means that r squared is really x squared plus y squared. What is z? Z is still z in cylindrical coordinates equals 1. Okay, so that means I have x squared plus y squared plus z minus 2 squared equals 1. Hopefully this looks a little bit familiar or almost familiar to something that you should recognize. If I gave you x squared plus y squared plus z squared equals 1, what is that? You know that's a sphere of radius 1. Radius 1, centered at the origin. 0, 0, 0. Right now, the only difference is that we have this z minus 2. So all this changes is like, what is the sphere centered at? So this is still a sphere of radius 1, but it's just centered at 0, 0, 2 instead. So this is a sphere. Questions on question 2? What is a half plane? Okay, so let me see. Where are my coordinate changes? Okay. Okay, so if we have, let me see, where is the, okay. If you ever have theta equals a number, that means that it's a half plane. If you ever get phi equals a number, which we've seen a lot in the Friday quizzes, right? That corresponds to a cone. And if you get rho equals some number, some like constant, that's a sphere. And you should also be familiar with this rho equals number is a sphere because like, how do we find the rho bounds if we have a sphere? Whenever we had a sphere in spherical coordinates, to get the rho bounds, we always went from like 0 to the radius. Why were we going from 0 to the radius? It's because the radius of the sphere is exactly how a sphere is written in spherical coordinates. A sphere is technically written as rho equals that number, which is whatever the radius is. Okay. So if you like, this is in spherical coordinates. If you set each of the things equal to constant numbers, like scalars, you get different shapes. You also have a similar thing for cylindrical coordinates. For cylindrical coordinates, if you set r equal to a number, you get a cylinder. If you set theta equal to a number, you still get a half plane. If you set z equal to a number, you get a plane, like a full plane. Should we know the equations for how to make the cone and the cylinder? You should definitely know the cone one because it has showed up on the Friday quizzes. Cylinder, I think also cylinder has shown up on the Friday quizzes. But like knowing the equations is like, do you know how to convert from Cartesian coordinates to cylindrical or spherical or the other way around? So as long as you know the conversions and you're able to like plug things in and solve for them, like that's the techniques that you need to be able to know how to do. Okay, and these are all on my recitation notes if you want to look back on these explanations. This is week 10 or week 9, maybe 11, maybe. Some of my numbers are mixed up, so I forget which week it is. But whatever week has the Cartesian, the transformations. Can you show us the cone formula? The cone is written as V equals a number. So these like dots here are meaning like numbers. Rho naught. Rho naught is like some number. And here I even have an example of like why is a cone equal to like if you're given this Cartesian equation of something and you don't know what it looks like, how do I know that it's a cone? Well, I can convert it to spherical coordinates. The conversions in spherical coordinates, z is rho cosine phi, x is rho sine cosine, y is rho sine sine. And so I can simplify this and I get the square root of rho squared sine squared, which is rho sine phi. So now I have this rho cosine phi equals rho sine phi. I cancel out the rows and I get 1 equals sine phi over cosine phi. What angle, like what tangent angle gives me 1? Phi of pi over 4 gives me 1. Pi over 4. So I took my Cartesian coordinate plane, I plugged in the conversions, simplified until I get a like something. Phi equals a number. And because phi equals a number, this tells me that it's a cone where half of its opening is pi over 4. That means the cone, half of its opening is pi over 4. So it's a cone of a total pi over 8 opening. If you were given the downwards, like the upside down cone, for example, this also showed up in one of the Friday quizzes. They gave it as z equals negative square root. You can convert to spherical coordinates and you'll get something like phi equals 5 pi over 6, for example. That means that it's still a cone of radius of an opening pi over 6. How do I know that? 5 pi over 6 is the angle that it makes with the positive z-axis. So that means that my cone, half of my cone opening is pi over 6. Okay, I didn't draw it like very well. Pretend this is like a vertical line here. And this makes up pi, right? So if the opening until I reach the cone is 5 pi over 6, that means half of the cone opening is pi over 6. Let me draw it better. This is the cone of pi over 6. Because when I solved, I got 5 pi over 6 over here. Okay. Questions on question 2? Okay. Let's see. Question 3. Convert the following to cylindrical coordinates. All right. What do we have to do? The 3 things we have to do: convert the differential, like the dz, dy, dx, convert the integrand, and also we have to convert these bounds. Okay, so first off, the differential we know in cylindrical coordinates, it becomes r dz dr d theta. And you can see that some of the answer choices actually switch up the order of integration. So we can be a little bit careful about that. But usually, yeah, we'll see what happens. Okay, but for now I know that this differential is like this. What is the integrand? The integrand in cylindrical coordinates, 5, x is r cosine theta. What is z? Z is still z, so z squared. So that's our integrand. So I know that in total, in my integrand, I have a 5r squared cosine theta z squared. So let's say integrand has the blue part, which is 5r cosine theta z squared, times the purple part, r dz dr d theta. So I need a 5r squared cosine theta z squared. 5r squared cosine. So this one doesn't have an r squared, so I know already that this one can't be right. This one also doesn't have an r squared, so I already know that's not right. So I'm left with these three options. Okay, let's look at the bounds. Let's look at the x and y bounds first. So these bounds are telling me that when I project to the xy plane, what do I have for my bounds? Y goes between negative square root of that. How do I recognize what that is? If y is negative square root of 4 minus x squared, let me rewrite it in different ways. It's like negative y squared equals square root of this. Oh, sorry, negative y only. And then I square both sides. So y squared equals 4 minus x squared. So this is a circle of radius 2. Circle of radius 2. Okay, so y goes from that negative half circle to the positive half circle. And out of all positive increasing lines I can draw in the y direction, x should only be from 0 to 2. So x should only be from 0 to 2. So I only have this half of my circle right now. Okay, so let's actually look at like what are these first two choices. What would my r and theta bounds be? Like after I do the z bounds, I like collapse the z-axis and I'm left with something, this projection in the xy plane. R goes from the center to the radius. So R should go from 0 to 2, which both of them have, okay. But what should theta go between? Remember, theta, think of as like the unit circle. It goes 0, pi over 2, pi, 3 pi over 2, 2 pi, right? The unit circle. Where does my region live? Where does this shaded thing live in? It lives in negative pi over 2 to pi over 2, which is this option. And actually, C is the correct choice. Let's look at what the Z bounds are. Okay, back to, does this so far make sense? Question so far.
Yes.
Okay, cool. All right, what about the Z? Z goes from negative of this thing to positive of this thing. Okay. If we're keeping things in dz, dr, d theta, what if I just convert the bounds to cylindrical coordinates? What is x squared plus y squared in cylindrical coordinates? It's r squared, right? And up here, x squared plus y squared is also r squared. So those are our bounds. All right, questions on question 3. Could you repeat how you got the bounds for theta again? Yes. The theta bounds, so we agree that this is my shaded in region. Theta, the reason why they write it as like negative pi over 2 to pi over 2 is because you always want like the lower bound to be a lower number and you want the upper bound to be a higher number, right? So I don't want to write 3 pi over 2 to pi over 2. That doesn't make sense because 3 pi over 2 is a bigger number. I want a smaller number. So what angle is 3 pi over 2 equivalent to? You can also write it as negative pi over 2. They're the same angle. So I go negative pi over 2 all the way up to pi over 2. Why is it a half circle again? Yeah, so we were looking at in the Cartesian coordinates, our bounds for y were the negative of the half circle to the positive of the half circle. right? So that means that when I draw a line in the increasing y direction, this red line enters the bottom half of the circle, and it exits the top half of the circle. Then I look at my x bounds, it goes from 0 to 2. So that means that out of all possible red lines I can draw in the increasing y direction, the smallest x could be is 0. And the largest x could be is 2. So I only want this region. If they had said x goes from -2 to +2, then it would be the whole circle. But they didn't say that. They said my x is limited. It can at smallest be 0. So the shape of the half circle comes from the bounds of x, y. The shape of the half circle I only use the x and y bounds to see this picture. The z bounds I found later by just converting the bounds to cylindrical coordinates. So realistically, the shape is something in like living in 3 dimensions. Like, what is the shape of z equals x squared plus y squared? What does that look like? It looks like, if you graphed it in Cartesian normal coordinates, it looks like a paraboloid. Why is it a paraboloid? Because I can plug in z values. And I see like for each z value, I get a circle of radius, whatever z was, or square root z. So this is some paraboloid. And when I projected down to the xy plane, I got that circle. And the circle is limited. So really in 3D, it looks like this. I have like half of the paraboloid-ish. Oh, wait. Never mind. This goes from negative of the paraboloid to positive of the paraboloid. So actually, when I draw a line in the increasing z direction, like this purple line, it enters after I get out of this lower paraboloid, and it exits as soon as I hit the upper paraboloid. So really, my region is like this weird middle part. Like think of what are those like time things that you flip over, and it's like that weird triangle-ish part. Okay. And when I project it down to the XY plane, I'm left with like a circle-y region. Yeah, hourglass. Thank you. Think of an hourglass, and it's like that weird like middle part. Don't understand why the bounds are not 0 to 2 pi. Am I doing it right? I think I'm doing it right. Y goes from, let me redraw this. I'm only going to look at the XY bounds, okay? Just from this. The XY bounds say X goes from 0 to 2, Y goes from negative this to positive this. Just looking at this itself, pretend this is a whole separate question. What does this region look like? Well, I look at Y, my lower bound says Y equals negative of square root. I simplify that so that I know what it looks like what is the shape, and I get this circle of radius 2. So I draw a circle of radius 2. The negative square root part is this lower part of the circle. That's this lower part. Okay, and the upper part of this upper bound, that's the upper part of the circle. Because that's when we have y of positive values, and this is when we have y of negative values. How do these bounds exist? If I'm doing dy first, that means I draw a line in the increasing y direction, and it enters the green first, and it exits out the purple. Okay, good. Then I do the x bounds. Out of all these possible red lines I can draw, my smallest x value I can have is 0. So I can't get a negative value of x. They're not allowing me to. X has to be at least 0. But it can't go on forever. I'm also limited by the fact that it can at most be 2. So I have to stop at 2. I can't get all these other stuff. So my region is just the half circle. Does this mean we are trying to convert between Cartesian and cylindrical spherical? We should visualize the shape by using the bounds rather than the integrand. Yes, don't look at the integrand to see what the shape is. The integrand tells you nothing about the shape. Don't be confused. The integrand is just ignore it. Just like convert it and be done with it. The way you get bounds and the way you see what shape you have is just looking at your bounds. The integrand tells you nothing about your region. So only look at the bounds to see like what shape do you have. Okay. Questions? Does this make sense? Half plane. Or I mean half circle, not half plane. Okay. Let's go to number 4. Consider the probability of picking a point at random from the unit cube, equipped with uniform probability density function, f equals 1. The expectation of this choice, that is, the average point, is 1/2, 1/2, 1/2. What is the variance of this choice? All right. First of all, what is the formula for variance? Do we remember the formula for variance? It's the integral of the length of x bar, meaning I have like some vector, minus expectation of that vector squared times the probability density dx. Okay, let's take this step by step. We have uniform probability density function of 1. Uniform probability density function 1. So that means that my rho, my probability density function, is 1. So that means I can simplify this to be, if this is 1 now, it's like 1. So I'm left with dx. Okay. All right. Let's not think of something so confusing like in Rn. Let's think of, what if we're only in 1 dimension? Okay. In 1D. Meaning I only have one variable. One variable. Like in 1 dimension, I only have one variable, right? Like 2D, I have 2 variables, x and y. So in 1D, I only have one variable, x. How do I write this formula if I only have one variable? Variance will be, if I only have one variable, x, that's only x itself, minus whatever the expectation of x is, all squared dx. And they're telling me, by the way, that the expectation in like all of the axes or whatever are 1/2. That means that like the expectation of the first variable is 1/2. The expectation of the second variable is 1/2. And so on until you get like to the nth variable. That's what this is telling you. The expectation of 1/2, 1/2, 1/2 means that the expectation in every single variable is 1/2. So that means that if I only live in 1D space, this will be 1/2. X minus 1/2. Length squared dx. Okay, what is the length of x minus 1/2? The length is, remember, the square root of each component squared. That means square root of each component squared. I only have one component. And then this squared comes at the outside. Let me do a different color. Squared. Dx. So this part was just the length. And so now this is, if I square root of squared, that cancels, but then I have another squared. So this is x minus 1/2 this squared dx. What are my bounds for this question? They tell me that I have a unit cube. So that means that x goes from 0 to 1. Unit cube is telling me like my bounds. X goes from 0 to 1. X minus 1/2 squared dx. Okay, let's quickly do this integration so that I could just show you what happens. X squared minus x plus a 4 dx. So I get x cubed over 3 minus x squared over 2 plus 1/4 x from 0 to 1, which gives me 1/3 minus 1/2 plus a 4th. In other words, 1/12. All right. Questions for the first dimension. I'm not done yet, by the way. Okay, that was in 1D. Let's try in 2D. Meaning I have two variables. X and Y, right? X and Y. What does my formula say? My formula says now that I do the length of this X underscore means that it's like the vector itself. Right now I have two variables, X comma Y, minus whatever the expectation of X, Y is, all squared dx dy. Question, is the magnitude not square root of X squared minus expectation squared? How did we get the square root of the whole thing squared? So if we have the magnitude of X, if I told you to find the magnitude of 5 squared, what is that equal to? The magnitude itself, let me do colors again. The magnitude itself is square root of each component squared. So 5 squared and then square root of it. But then I also took a square of it, of that. And so in here, the square root and the squared cancel out. So I have 5 squared, which is 25. So similarly, I have this inner thing squared, but all square root. That's the magnitude. And you see that the square root and the squareds cancel out to just be x minus 1/2. And then we have the squareds in the orange. So your question is asking, why didn't I do just, why is it not just x squared minus 1/2 squared? Notice that x squared minus 1/2 squared is not the same thing as the parentheses squared, because this is not equal to this, right? You can't just distribute the squares itself. It has to be everything together squared. This is like one term together squared. If they were asking for the magnitude of like x comma 1/2, then yes, that would be square root of x squared plus 1/2 squared. But we're not asked to do that. We're asked to do it together. Okay, continuing. So this is, now here I have a vector minus, let me just write it out step by step. A vector, what is the expectation of x and y? They're both 1/2 and 1/2, as they told me in the problem. Okay, so now I have a vector minus a vector. How do I do vector subtraction? I subtract things component-wise. So this is x minus 1/2 comma y minus 1/2 squared dx dy. Okay, what is that? Let me make this magnitude in like red so it's not confusing. What is the magnitude of that? It's square root of each component squared. So the first component squared plus the second component squared. Okay, and all of that squared dx dy. So now this squared and this square root, they'll cancel. This one with this square root cancels. So I'm left with x minus 1/2 squared plus y minus 1/2 squared dx dy. Oops. And remember, I'm in a cube, so my bounds are 0 to 1, 0 to 1. You can solve this and you get 1/6. Everyone with me so far? Questions? Okay, I'm gonna make this smaller. Let's try in 3D. Or let me not write everything out in 3D, but you can try it yourself. You'll get an answer of 1/4. You can do it again if you want in 4D, right? You could keep going. Do I see a pattern here? Notice that the denominator, yeah, if you write the 1/6 as 2/12, the pattern should become a little bit more obvious. And 1/4, what is 1/4? It's 3/12. So every time I'm increasing the numerator by 1/12. And what does the numerator correspond to? Well, in 1D, I had 1 in the numerator. In 2D, I had a 2 in the numerator. In 3D, I had a 3. So this is n over 12. Whatever dimension I'm in, divided by 12. So you've seen how this question itself was kind of confusing. You're like, what do I even do? But if you start testing out like smaller instances, like if you're really completely stuck, try testing out smaller instances and see if you see a pattern. And we did see a pattern. So we got n12s. So do you just do it for each dimension and find a pattern? Yeah, at least that's what I did. I think this is the clearest way to see the pattern. Yeah. Any other questions on number 4? Select the best choice. Let's look. A is a 3x2 matrix. B is a 2x3 matrix. So AB will be a 3x3 matrix. BA will be, well, B is 2x3, A is 3x2. So I take the first number and the last number, it's going to be a 2x2 matrix. Questions? Okay, 7. Here are some matrices. Select the best choice. All right, so all of these are having to do with like invertibleness. Note that here, choice C is a very, like when you see choice C, you should think, no, that's not correct. Why? Because I said in the review session that this is only true if A and B are both square. Because some people say like, oh, determinant of AB must equal determinant of A times determinant of B, and you see, oh, A is not square, so you think, oh, this determinant doesn't exist. That's not true. You could still multiply A, B together first, and the determinant might exist. So you can only use this rule of A, B only if A and B are both square and invertible. Maybe square works itself. Okay. So what is AB? AB is going to be this matrix times B. Let's see if it's invertible. What do I get? I get 2 minus 1, which is 1. All right, this is the matrix I get. 2, 3, 9. What is that determinant? The determinant is 1 times, I'm going to do 1 times this, which is 1, 3, 3, 9. So that's 9 minus 9, which is 0. So AB is not invertible. Is BA invertible? BA, I get 8, 14, 1, 3, which has a determinant of 24 minus 14, or 10. This is not 0, so BA is invertible. The answer I got is D. Questions? Okay, question 8. The general form of the quadratic function in 2 variables is that, and if we know that the origin is where we have a local max, what can you conclude? How do I know that it's a local max? Well, I see this function. I could take the derivative, and I could take the derivative again to get the Hessian matrix, right? So if I take the derivative of f, what do I get? The partial with respect to x is b plus 2dx plus ey. What's the partial with respect to y? It's c plus ex plus 2fy. Then I'm going to find the Hessian matrix. So I take the partial of this with respect to x again, and I'm left with 2d. What is this, the partial with respect to y? It's e. E, e. And the partial with respect to y of this is 2f. So this is my Hessian matrix. What were the rules that told me if I have a local max? I have a local max if the determinant of the Hessian matrix, first of all, it has to be greater than 0, and then the trace has to be less than 0 to be a maximum. All right, so what is the determinant of d squared f here? It's 4df minus e squared, and I need that to be greater than 0. In other words, I need negative of 4d of e squared minus 4df to be greater than 0. So e squared minus 4df, when I like distribute that negative sign, swaps. So how do I solve this? Oh wait, let me continue. E squared less than 4df. Okay, now the signage is always like a problem. Like, is E less than and greater than something? Or is E less than or greater than something? Which one do I use? Let's think about a separate example. If I had 4 less than, let's see, if I had x squared less than 1, what is the solution to that? It's less than 1 and greater than the negative of it, right? If I had x squared greater than 1, well, the answer would be x greater than 1 or x less than -1, right? So because we have something less than this, I can use this first way. So E is less than the square root of 40f, and it's greater than the negative of the square root 40f. In other words, it's less than 2 square root df and greater than -2 square root df. So I already see that option here. Okay, but let's continue. It's either here or... All right, wait. Okay, so we haven't finished though. So that's just a determinate condition. Let's look at the trace. The trace is going to be 2d plus 2f. And I want that to be less than 0. What does that mean? It means 2d plus f has to be less than 0. So d plus f has to be less than 0. All right, where do I see a d plus f less than 0? I see that here. I see that here. D plus f here is greater than 0, so that's not an answer choice. All of these are negative. I don't know how to get from that. Well, if all of these are negative, oh, I guess that could work. But why would all of the rest be 0? Does that work? Well, this doesn't tell us anything about our determinate condition. So A is like also not on the list. So we're left with B and C. All right. Let's see. They both have B equals C equals 0. And over here, we have E is less than this and this. So I would say the answer is C. Because we have this condition from the determinant, and we have that trace condition. Okay, questions? How do we know for sure that B equals C equals 0? It works, but we are supposed to know for sure. Choose the best, most informative answer. We know that it has a local. Let me think. If B equals C equals 0.
If they equal 0, it definitely works because they're not in the Hessian when you take
Yeah.
the second derivative.
Yes.
But
So the question,
how do we know it's not E?
okay, so the question is, we know that we have a local max at the origin. Oh, okay. We need B and C to equal 0 because how do you find a critical point? You take the derivative and you set it equal to 0, 0. And if at the origin, what is x and y? X and y are both 0 at the origin. So when I plug in 0, 0, 0, 0, what am I left with? I'm left with B equals 0, C equals 0. So B and C have to be 0. Yep. So that's also good condition. All right. Questions? Let's move on to 9. We're going to pick a point in the unit cube with an associated probability of that. What is C? Let's remember, what does it mean to be a probability density function? It means that the integral of your probability density function equals 1. So that means that 1 has to equal the integral of my probability density function, this thing. All right, what are my bounds? I have a unit cube. So all the bounds are 0, 1, 0, 1, 0, 1, 0, 1. x2, x3, x4. We know a trick from the earlier weeks. Oops. What's another way of rewriting this? All my bounds, I have like a rectangular, or I guess a cube region specifically. All my bounds are numbers. This expression, I can write them separately as some expression with only x1s times some expressions with only x2s, some expressions with only x3s, some expression with only x4s. So because everything's like very separate, like we're allowed to like take them out separately and multiply them individually. So this is C, 0, 1 of everything with x1s, everything with x2s, everything with x3s, and everything with x4s. We can do this only because my expression, I can take them like, I can separate them kind of as through multiplication. If your integrand is something like x1 plus x2 squared, you can't separate that into some portion with only x1s times some portion with only x2s. So you wouldn't be able to use this trick if your integrand looks something like that. Okay, so so now we can just evaluate, right? What is this? This is x1 over 2 squared, 0 to 1, x2, wait, x2 squared here, 3 and 4. Okay, x2 to the cubed over 3, x3 to the 4 over 4, x4 to the 5 over 5. So I get C 1/2, 1/3, 1/4, 1/5, which is C 1 over 20th. And that all equals 1. So that means that C equals 120. Questions on 9. All right. I'm going to keep going. 10, use the probability density function in order to compute the probability that something is chosen between x1 and x3. Wait, a chosen point has x1 less than x3 and x2 less than x4. Okay, first of all, observe that the condition is met by 1/4 of the cube. Well, first of all, this x1, think of this as like this is some diagonal. Something's happening in the diagonal, right? Something over here is also happening in like a diagonal, because if I only wanted to draw like the x1, x3 coordinate, x1 less than or equal to x3, let me switch the axes. Let me make this 1 and 3. This is the line x1 equals x3. Think of if I just wrote y equals x, y less than or equal to x. But in this case, I have x1 less than or equal to x3. So that's this part. If I just wanted to look at the projection of x2, x4, what would that look like? I have x2, x4. x2 is also less than or equal to x4. So I have this bottom part. So let's look at all of our bound choices. Let's see. We always want to start with whatever variable depends on other variables. So notice how they start with like x1 here. Sure, I could start with x1, but that means that my bounds would have to be like x1 is less than x3. So like it's bounded by x3, but here they're telling me it's bounded by 1. That can't happen. So C is not correct. Let's look at choice D. Let's look at choice E. x4 has to be greater than or equal to x2. So that means that the minimum of x4 is x2. So x2 should have been our lower bound, but they're writing it as the upper bound. That's not right. What about choice D? x4 they're saying is between x2 and 1. x4, they told me was greater than or equal to x2. So that means that x4 is greater than x2. Is it bounded above by anything? We use the probability density of the previous function or the previous problem, which we had a cube, right? So no matter what, we're always bounded by 1. So x4 has to be less than or equal to 1. In other words, if x4 has to be greater than 2 and less than 1, right, this is where x4 lives in, it makes sense that x2 is the lower bound and 1 is the upper bound. That's good. x1 less than or equal to x3, that means that at most it could be x3. We're also bounded by the square, the unit cube conditions, so it has to be greater than 0. This is where x1 lives. So we have x1, oh, what? Sorry, the next bound was x3. So x3 is greater than x1, but it's bounded by the unit cube, so this is where x3 lives. So it's x1 to 1. That's this bound. Now that we have finished all the constraint stuff, we just have the cube constraints. So x2 is 0 to 1, x1 is 0 to 1. The choice is D. These other ones, we don't know, like, we don't know, is this a quarter of the cube? If you can visualize it, maybe it's hard to visualize, but I don't think it looks like a quarter of a cube. And it doesn't look like half of a unit cube to me. And this thing just doesn't make sense. Like, what PDF is increasing as each coordinate increases. So the choice should be D. Questions on 10? Okay, 11, consider the double integral where D is the region defined by that plane. If we use a change of variables, then the integrand is what? So here they're asking us to rewrite the integrand in terms of u's and v's. Can we do that? Well, let's look at the choices. So the way I would do this is honestly just to test each one. You know that it can't be negative a fifth u, because that would give me negative a fifth xy squared only. That's not equal to the integrand, so it's not these ones. Does uv to the 4/3 give us anything? What is uv? uv is xy squared, v is x squared y, so that's x cubed y cubed. That means that uv to the 4/3 is x to the 4th, y to the 4th. Let me write it out. X cubed, y cubed to the 4/3, or in other words, xy all cubed to the 4/3. So the 3's cancel. So it's xy to the 4th, i.e. x 4th, y 4th. Okay, so that gives us something. But if I multiply by that by u, well, now I have too much. Like u gives me another y squared. But I don't have a y6 here. So it's not these two. So all I'm left with is this one. uv to the 2/3 times u. Well, what is uv? uv is x cubed, y cubed, all to the 2/3. U is xy squared. So this is x squared, y squared, xy squared, which is x cubed, y to the 4th, which is what we wanted. And there's the 5 up there too. Questions on 11? Okay, let's go to 12. Consider the double integral where D is that region. Then this change of variables is what? So orientation preserving. So you want to think of like when you see orientation preserving or like sign, whatever positive, negative stuff, think like determinant. So in a standard basis, the usual basis that we think of, that's made of like the I vector, 1, 0, 0, 1. That's what we think of as the normal, that's our perfect normal world. What is the determinant of that matrix? It's 1. So anything that has the same sign as this, meaning it's positive, that means it's orientation preserving. It uses the same kind of format as the standard basis. If we get a determinant that's negative, that means we're going against the standard basis. We're going in the opposite way. For the previous question, why don't we need to compute du dv using change of variables and then simplify the integrand? I got choice B when I did this method. Ah, maybe I forgot that part. Good point. So this is not the correct answer. So, okay, so you have to do the whole like change of variables thing. So thanks for pointing that out. Change of variables. All right, in change of variables, what is dy dx equal to? Let me just say dx dy. It's equal to the absolute value of the determinant of this matrix where you have x and y as the outputs, And what are our inputs? They're u and v. U and v. du, dv. Okay, but we don't have x equals something, y equals something. We only have u equals something, v equals something, but that's okay because this is the same as 1 over the determinant of u's and v's as the outputs. And x and y are the inputs. du, dv. Okay, so what is the determinant? What is this matrix? The partial with respect to x is y squared. With respect to y is 2xy. This with respect to x is this, and y is x squared. du dv. That's 1 over y squared x squared minus 4x squared y squared du dv, which is 1 over negative 3x squared y squared. So that means that in our integrand, we have 5x cubed y to the 4th. dy dx is now negative. Let me do a different color. Negative 1/3 x cubed y squared du dv. So let's see what cancels. The x cubed cancels. The y, we're left with a 2. So this is the integral of negative 5y squared 3 du dv. Did I do choice B? 5/3 u xy squared. Maybe I missed something. X squared. Oh, why did I put a cube? Wait, this is squared. So this is actually a squared. So the x, we are left with a single x. So xy squared, which looks to be choice A. Okay. Questions on, yeah, thanks for catching that. Oh wait, absolute value. No, I forgot. My bad. B. We need to take the absolute value of everything. So choice B is the correct answer. Because when we're doing the change of variables theorem, I didn't continue writing those absolute values. du dv. Perfect. Okay. So that was 11. Back to 12. All right, so determinant, if it's positive, orientation preserving. Negative, orientation reversing. If we get a number bigger than 1, then we're area expanding. Why? Because the determinant of two vectors, like u and v, is calculating like the area of the parallelogram spanned by u and v. So if we get that the area is something like bigger, that means that we're trying to like expand the area. If we get a determinant that's smaller, that means we're trying to like compress the area contracting. So let's see, from our determinant, I already did the determinant up here, right? And I got negative 3x squared y squared. So because this is a negative sign, it's area orientation reversing. And because it's some like positive, it's like a bigger number. We have this 3 here instead of like a 1/3 or a 1/2 or something. So it's area expanding. So B. Okay, questions on 12? Could you repeat the area expanding? Yeah. If you take the determinant and you get a number bigger than 1, then it's area expanding. If you get a number less than 1, then it's area contracting. Other questions so far? For 11, how do you get dx dy? 11, yeah. dx dy by the change of variables theorem is equal to the absolute value of the determinant of your derivative matrix. where in your derivative matrix, the outputs are like whatever, the way I remember it is that the outputs are whatever I wrote over here. So X and Y are the outputs, so they're in the rows. And the inputs are whatever I write over here, which are U's and V's. Those are the columns. But I don't know how to find this determinant because this requires me knowing like what is X equal to and what is Y equal to. So that I could take the partial of this with respect to U, and that's over here. And this, the partial with respect to U would go over here. But I don't have that. All I know is that U equals this and V equals this. So I need some matrix where U and V are the outputs. So what's the way that what's the relationship between having X and Y in the outputs versus U and V in the outputs? Well, I can just take a reciprocal. So this is equal to 1 over the determinant where U and V are the outputs, X and Y are the inputs. This is by the change of variables theorem. And so we calculate that matrix, get the determinant, absolute value. And to check how the orientation changes, how do we know which matrix to use the determinant for? Wasn't sure whether to use the negative 3x or the reciprocal. Well, we can't find the other, we don't know how to find this one. We only know how to find this one, so use the one you can find, which is the negative 3x squared y squared. Oh, I guess. Actually, because we could do 1 over that, and then we would get a third. But maybe someone else on ed discussion to confirm. For reference, like there's like no answer key, so I don't know the correct answer. This is just my work that I am doing and sharing with you guys. For 12, when we say it's area expanding, that means determinant is greater than 1, but isn't it negative? When we say area expanding, but isn't it negative? Yeah, it's okay that it's negative 3 because negative 3 just means expanding in the opposite direction. So for expanding, contracting, just look at the number itself. And for orientation, look at the sign. For 12, how do we know which determine? Yeah, please ask on ed discussion. Okay. For number 13, consider the linear transformation of the plane. Which of these matrices represents this linear or transformation? Okay, how do we do linear transformations, right? It's always whatever's in the first column. First column is what happened to the I vector. And the second column is what happened to the J vector, 0, 1. Okay, so let's see. If we had an original I vector over here, there's multiple ways of doing this question. I guess if you want to rotate first, let's see what happens. Let's say we rotate by 90 degrees. What's the rotation matrix? It's cosine, sine, negative sine, cosine. And when we plug in 90 degrees, what do we get? We get 0, 1, negative 1, 0. So once I rotate counterclockwise, my smiley face looks like the dot is over here, the rectangle is here, and the smiley face is like that, right? Okay, and then let's see what happened. There's this like, the x-axis stayed the same. So the x-axis stays the same, but the y-axis shrinks. So I want to shrink the y-axis. Shrink y-axis. How much do I want to shrink it by? Well, originally the length was 3 here, and now it's only 1. So I shrink it by a third. So the x-axis stayed the same. Y-axis, I shrunk it by a third. So now it's a skinnier smiley face. Like that. So if I rotate first and shrink next, how do I multiply them? Remember, you multiply right to left. So whatever I did first was the rotating, and then I did the shrinking. This matrix multiplication gives me 0, a third, -1, 0. So C. This is one way you could have done it. Let's say instead you wanted to do the shrinking stuff first and then the rotating. Let's see if we get the same answer. Okay, let's see. I didn't shrinking. So it looks like the eyes are getting smaller. So if I shrink first, I'm really shrinking the x-axis. Shrink x-axis. How much am I shrinking it by? Well, I want to shrink it by a third, right? So it becomes a third 0. So now my smiley face is like a shrunken smiley face dot the rectangle smiley. Okay, and then I rotate by 90 degrees counterclockwise. That matrix is still 1, 0, 0, 1, -1, 0. So then I rotate it. So now it's like this. Okay, so first I shrunk it and then I rotated. Let's see, I get 0, 1/3, -1, 0. Same answer. So you could do it either way as long as you're making sure you're keeping track of like the order you multiply things in. Questions on 13? Okay. 14? You know that df of that equals that and dg of that equals that. What else do you know? So this requires like one of the past quiz questions, right? Which I also went over during my review session. There was that one quiz question where it was like, if you want to show it's invertible, what do you need to know? If I want to show that f of g is invertible, then it's only invertible if its derivative is invertible, right? And what is the derivative equal to? By the chain rule, at some point, it's equal to df g of a times dg of a. So before I even see if it's invertible or not, I have to be able to like compute this first. If I can't even compute this, then I can't even test if it's like invertible. I can't even know what its derivative is. So we need to be able to calculate this, meaning these inputs must be matching. So 0 of 0 has to equal g of 1, 2, 3. Do we know that? They don't really tell us anywhere. So I would say that we can't make any conclusions because they didn't tell us this. If they did tell us this, then you would find the derivative matrix, take the determinant, and if it's non-zero, then it's invertible. Questions? Okay, 15. Let's think about these two linear transformations. A is represented by that. AB sends ij to that. Which of these matrices represents B? Okay, so what do we know about linear transformations? I said that to find a linear transformation, you see what happened to the ij vector and what happened to the I vector is the first column. What happened to the j vector is the second column. So the fact that it says AB sends I to that and j to that, I know that AB has to be 4, 10 and -2, 1. Because whatever AB did, what happened to I? It became 4, 10. That's what they said. What happened to j? It became -2, 1. So I know this. And they're telling me that A equals 2, 1, 4, 3. Well, how do I solve for B? B will equal, so I know that, like, how do I get B? If I know what AB is, I could multiply by A inverse. Then I'll get B, right? So if B equals A inverse AB, what is A inverse? If A is this, the inverse is 1 over 6 minus 4, 3, 2, negative 1, negative 4. A itself is 2, 1, 4, 3. And wait, sorry. A inverse is that. And then AB, let me put it in green. AB is 4, 10, negative 2, 1. So I get 1/2 of negative 28, negative 10, 16, 4, which is negative 14, 8, negative 5, 2. For question 13, what is the rule for finding the linear transformation matrix? Like, is it the second transformation matrix multiplied by the first? Which order do we multiply them? We always multiply whatever started first, you write on the right-hand side. So if I shrunk X first, I write it here, and then I rotate it. So if your order of transformations was the matrix, like you did some A first, then B, then C, you should multiply like A, B, C. This will be your matrix. So multiply them starting from the right to the left. Whatever you did first is on the right, whatever you did last is on the left. Okay, questions on 15. Okay, and question 16. Which of the following of these forms is the differential of a scalar function? So let's recall from my little summary, what is the relationship between the vector language and the forms language? Which hopefully I have it. I should have it somewhere here. Yeah. The relationship between the forms language with like scalar functions, vector fields, gradient curl divergence, and their respective forms version. Well, any scalar function is written as a zero form. What is a zero form? It's that function itself. Like if I have some scalar function 3x plus 2y, the zero form is still 3x plus 2y. If I wanted to take the gradient of this, what do I get? The gradient of f is 3, 2. So it's corresponding one form. One form are like it has a dx and a dy. So I would say that it's 3 dx plus 2 dy. The two form has like the two wedges. It would be for some other example. So I'll change a color. For some other example, it'd be like whatever number you want, dx wedge dy plus whatever. Let me write it in the correct order. It would be dy wedge dz. Let me say we have some vector field, f1, f2, f3. The two form would be f1 dy dz plus f2 dz dx plus f3 dx wedge dy, right? So if we have a scalar function in this question, the forms language of it is the same thing. So I would say that it's none of these. Because this is a one form. This is also a one form. This is a two form, and this is a two form. Questions on 16? If we had a three form, would that be the answer? If we had a three form. If you had a three. Oh, like what would be the answer? Three forms are scalars. Three forms are like the, oh, I see. Yes, if they said like, which of these? It depends on, yeah, I think that's a tricky question because they would have to distinguish like, are they talking about this scalar function or are they talking about this scalar function? Like if you have a scalar function, yes, you could say that it has a corresponding three form written in like this way. Question 15 was this stuff. which said that AB sends this I to that, J to that, so we know AB must be that. What's another way of writing B? Well, if I do A inverse AB, A inverse A becomes the identity. And so B equals A inverse AB. So I was given A, I can take its inverse. I know what AB is, which I found in the green, multiply. Questions on 15 or 16? Okay. And as I said, I'll preface that like there are no like formal answer keys. The professors didn't give us any of these answer keys. So this is all of my own work. If you find typos or think something else is the correct answer, please let me know. All right, let me end the recording.